Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is word pattern. Given a pattern and a string S, find if S follows the same pattern. Here, follow means a full match such that there is a bijection. A bijection. I learned a lot of new words in these challenges. Between a letter in pattern and a non-empty word in S. To be honest, I don't know what that means. But let's take a look at the examples. Input pattern A, B, B, A. And the string is dog, cat, cat, dog. All right. Example 2, A, B, B, A, dog, cat, cat, fish. That doesn't work. Example 3, A, dog, cat, cat, dog. All right, well, I think I see what we're trying to do here now. Constraints. Pattern length will be between 1 and 300. Pattern contains only lowercase English letters. The length of the string is between 1 and 3,000. The string only contains lowercase English letters and spaces. S does not contain any leading or trailing spaces. All the words in S are separated by a single space. Yeah, you probably can't really see the full method signature. There it is. We get a pattern and we get a string. So, I see what's going on here is that each letter in the pattern has to match to a unique word in the string. So, this is actually so similar to the previous problem, which was the isomorphic strings, that I'm just going to copy this. I mean, it's not exactly the same, but it's pretty close. I mean, that one was matching characters to characters. This one is matching characters to words. But let's paste it in here and modify it accordingly. So instead of a map of character to character, we're going to have a map of character to string. Actually, let me scoot this over so we can see it. Char, C equals A. So that was for reading the hash map. In this case, what we're going to have, we'll read the hash map, but we'll read a word out of the hash map. Just initialize it to an empty string. The other thing we need to do here is we need to convert the string S into an array of words. So let's do a string array. We'll just call it ARR equals S dot split, and we'll split it on a space character. Okay, how does that look? All right, now we can start going through the pattern. We can say for int I equals 0, I is less than pattern length. Oh, wait a minute. You know what? Let's do a quick edge case check here, because it doesn't guarantee that the number of letters in pattern is going to be the same as the number of words in strings. So we could wind up doing a lot of work for nothing. So let's say if pattern dot length is not equal to array dot length. Whoops. Then we'll just return false. Okay. Yeah, it's good. All right, so we'll go through the pattern length. S char, it doesn't have to be S char. There's only one char this time, so let's call it char C equals pattern char at A. And then we'll do string str equals, what did I call the array at index I, right? All right, so we've got the character and we've got the string. All right. Is the character in the hash map would be the next question. It's not S char anymore this time. It's C. If the character is in the hash map, then let's get the corresponding word. And we called that word. All right. If the word is not equal, if not word equals str, return false, because we're trying to, that means that we're trying to map a character to more than one word, and we can't do that. All right, next, if we've got to check, is the word in the hash map? And it shouldn't be, because we've already checked for the key matching the word, the character matching the word. If the word is in the hash map, it means it's mapped to a different character, and that is bad. So if not hash map contains value str, if that string is in the, well, let's do it this way. If it's not in the hash map, that's good. So we'll put the key value pair in the hash map, the character and the string. If it is in the hash map, that's bad. And we're going to have to return false. If we get all the way through the pattern and we haven't returned false, then we will return true. And it looks good enough to try and run it. See what happens. Let's pull this up. All right, so the basic cases are accepted. Let's pull this over, move the frame so we can see the results, and submit. All right. So it looks like 1 millisecond was a pretty common result as far as the timing. Let's see, memory. Oh, memory we're doing pretty well. I don't know why. I mean, we've got a hash map. We've got a hash map there. I don't know what people are doing to use more than just a basic hash map on the memory, but that is the solution. This, by the way, is rated as an easy problem. And I think it is an easy problem, and it's an even easier problem if if you did the one yesterday, if you did the isomorphic strings first, because the problems are so similar. I encourage you, and I mean, you wouldn't be able to do this, in an interview, but in an actual coding job, I'd encourage you to, if you are given a problem to solve, to think about whether or not you've solved a similar problem in the past, and reuse as much code as you can. In an interview, you pretty much have to start from scratch, but in in real life, reusing code is a good thing. So that's it for word pattern. Feel free to like, subscribe, comment, and see you next time.